The vehicle speed signal from a Mazda MX-5 NA Miata is generated in the instrument cluster. So we need to pay attention to the input from the speedometer cable and the presence of the reed switch, which is indicated by the label RSW on the back of this instrument cluster. Once we have removed the speedometer from the instrument cluster, we can see the element that we will call the reed switch here on the side, and this is also where the two screws go in that you saw earlier on the back of the instrument cluster. So I have another reed switch over here, and then you can look at it in a bit more detail. The reed switching part is actually the part where we have two contacts inside of a glass housing with some gas inside, and these two contacts are normally not touching each other. That only happens when a magnetic field influences them, and then the two contacts are pulled together and make a connection. With a multimeter we can test for continuity. As you can see, currently there is no continuity through the switch, so the switch is open. We call that normally open. When I move this inside a magnetic field, for example from this speaker, then it makes a connection. That's what you can hear and what you can see on the multimeter. So do that again. So if it is within reach of the magnetic field, the two contacts are pulled together and the switch is closed. So currently it's open. Now it's closed. This is also what happens when the reed switch is installed in the speedometer, but then there's a different mechanism that makes sure that we switch between open and close for the switch through a magnetic field that changes. Inside the speedometer there is a disc with a number of magnets inside, and this disc will spin when the speedometer cable is rotating. So as you can see here, I'm now using an Allen key to simulate the rotation of the speedometer cable, but the disc that spins is responsible for creating that magnetic field or the changes in the magnetic field. During normal operation, the speedometer cable will turn counterclockwise. And during that rotation, the magnetic field changes. So the switch is currently open, now closed, open, closed, open, closed, open, closed, and open again. This means that during one rotation, the signal changes 8 times. It will be 4 times open and 4 times closed. From the cruise control module, you can expect to get a 5-volt signal on one of the contacts of the reed switch. When the switch closes, it means that the signal is grounded to 0 volts, which means the signal alternates between 5 volts and 0 volts from the perspective of the cruise control module or the PCM or any other device that is listening to this signal. So the frequency of this signal is a measure for how fast the car is driving. So the higher the frequency of this alternating signal, the higher the speed of the car. That's also how the cruise control module, for example, is informed about the current speed and what it needs to do to maintain that speed. There are 2 ways to get the vehicle speed signal from the instrument cluster. Either you connect a wire with an eyelet underneath this screw labeled RSW, or you follow that lead, which leads to pin F here at the connector, and you use a wire with the correct terminal for this connector to pick up on the signal from this connector. So either an eyelet over here or a regular terminal in the connector over there. In case you need the vehicle speed signal, for example for a standalone ECU, but your instrument cluster does not have this reed switch, then there are 2 options. You could find the reed switch in the NA Miata instrument cluster or in a European cluster from a car with an automatic transmission. The other option is that you would produce something yourself. The part with the glass element, the actual reed switch, is very inexpensive. It's roughly around $1. But then you would have to produce what you could call the holder, and the part that connects it to the speedometer and that makes the electrical connection with the flexible print on the back of the instrument cluster. Probably you could 3D print that. If you would have the reed switch, you would need to bend the legs of that component, but making sure that there is no strain, no pressure on the glass housing, otherwise you will break it. And then these legs should be connected to something that conducts electricity towards these screws. If you've liked this video, then please hit the like button and subscribe to the channel. All of your feedback is welcome in the comment section below. And for now, I would like to thank you for watching MX5 Info.